our lemniscates, we enter our third category, not to be confused with a limison or a rose curve. The format is virtually identical to what we saw yesterday, except for what? R squared. So it's R squared equals A sine of n theta, or R squared equals A cosine of n theta. We're going to still graph 4 sine 2 theta, two-dimensionally. So we have a period change. Period's just pi. We have to get a sine curve in by the time we reach pi. Amplitude of 4. It did? The issue we're going to deal with, though, here is, this is 0, 0, obviously. What is this point? Pi over 4 what? Yeah, is it 4 or 2? Because we graphed R squared, so I think this is R squared. But let's see via a table of values. If I plug in pi over 4, so R squared equals 4 sine times 2 pi over 4, that's going to make pi over 2. What's the sine of pi over 2? 1. 4 times 1 is 4. So then R equals plus or minus 2. So this is going to take some exploring. So pi over 4 gets paired with a radius of plus or minus 2. Okay, so Josh thinks it's got to be positive because it's above. Let's see if it even matters. Then we have pi over 2, 0. Now here's going to be the interesting part. If this is the 4 sine of 2 theta, this whole graph is, since it equals R squared is always what kind of a number? Positive. So if 4 sine of 2 theta always has to equal a positive, then this can't be, because that's negative. So we would reject this entire piece. 4 sine of 2 theta, this graph, given that it equals something squared, always has to be positive. So this section of it that's negative, get rid of. Then we'll pick back up with pi 0. This is going to be 5 pi over 4. Again with plus or minus 2, do you think? Right? And then back to 3 pi over 2, 0. Stephen, did you have a question? Yeah, there are symmetry tests with even, odd. Sine is odd. Two-dimensionally, that means it's symmetrical with the origin. So if I plug in a negative theta, I'll get a negative answer. We're not going to go down that avenue, but there is some symmetry testing that can happen. You probably noticed it in your directions, right? So it'd say like graph based on symmetry. we're just using this method, the two-dimensional way. Okay, so let's see what we make of this. So, is it fair to say that as we move from a theta of 0 to a theta of pi over 4, all of these coordinates will have a plus or minus r value along the way? I mean, I know we only technically figured out this one, but if we ever plugged in another point, we would still have the same taking the square root of both sides plus or minus issue. So starting at 0, 0, and then we'll first head off towards positive 2, pi over 4 with a positive 2, which is here, and that would bring us that way. But there is also the possibility that, what's also happening, not the possibility, it's also happening that we're going towards pi over 4 with a negative 2, which would be here. So a bunch of first quadrant angles that are also getting paired with negative r's would create a connection that way with pi over 4 negative 2. Yes? These theta inputs with the positive r values swings this curve this way, but these positive theta values with negative r's are going to touch on this area, which is going to connect those points that way. Okay? 1 second, Stephen. Staying on the positive r side of things, we are then returning to the origin by the time we reach pi over 2. And staying with the negative r's down here, still quadrant 1 angles, but with negative r's, we're also returning to the origin. So we get that. Stephen. Your overall graph can only equal positive numbers. So my overall graph equals positive numbers here. But that's just talking about r on its own. Because when we solve the equation and we square root both sides, r can be plus or minus. R squared, though, is always positive, which means whenever this graph equals negative r squared values, that won't happen. This is technically negative r squared values, so this whole thing won't happen. It's just this. So we've got an r squared situation happening and an r situation happening. So if we jump now to here, we're going to pick up at the pole again, and we head off towards 5 pi over 4 with a positive 2, which we already have. And a 5 pi over 2 with a negative 2, we already have. Not 5 pi over 2, 5 pi over 4, sorry. So this section of the graph really is just going to retrace this section anyway. Yes? So to be honest, even if I had forgotten, good morning, even if I had forgotten about the plus minus, it still would have panned out because we would have hit just the positive side here in quadrant 1, and we would have hit the negative side over here because we're dealing with a third quadrant angle, positive r, we would have hit the third quadrant anyway. So it would have been salvageable. But that's it. That's the graph. Okay? So like a rose curve, but you're missing 2 of the petals because it's no longer r equals, it's r squared. Any questions on that? Yeah. This is no longer a rose curve, so those rules aren't happening anymore. Yep, so the rule about the number of petals, even, odd, is only for rose curves. I'm going to call these petals because obviously they still look like petals in a way, but it's not the doubling rule, not on the table because it's not a rose curve. Okay? All right. Why don't you take a moment and try this one, which has only been changed how? Just a sine has become a cosine. So take a minute and try this one on your own. And then we'll kind of compare and contrast the cosine. How's it going? Good. We're getting healthy and we're getting hustle. We're getting it. Oh my God. My 6-month-old got it so hard. Kind of scary. We'll look at that the other day. Oh yeah. I mean, that was the front end. That's not what scared me. What scared me was like coughing so hard he was choking. That scared me. Label some critical points. Yeah, you got it. Yeah. No, that will, just like the rose curve one doesn't categorize the rose curve, we can look at it just out of curiosity. In fact, I will because I'm also interested, but it wouldn't classify as this. I didn't know that. So, if you had to generically describe the shape of a lemniscate, what kind of descriptors would you use? Oh, an infinity sign. I was going with a figure 8 in my head, but I like that. Very good. Okay. So, Connor, can I steal yours, please?
Okay, sure.
How's it going? Oh, it went well. Okay. So we have 4 cosine 2 theta as our guide. We have a change of period, so we've got 2 cosine cycles. It's r squared, so it can never be negative, so we cross that off. All good. And then he takes his critical point, which is 0, starting with a radius of, well, r squared is 4, so the radius is 2. So he starts here, and then he goes back to the origin on the positive side. He also started here and went back to the origin on the negative side. Then when we go from the origin to pi 2, so here's pi 2, going from the origin to pi 2, we're dealing with third quadrant inputs with positive r values. So here's I'm sorry, second quadrant, prior to pi. Second quadrant inputs with positive R values, puts him through the second quadrant, and then the plus or minus consideration, second quadrant values with negative R values, popped us back into quadrant 4. Taylor says the infinity sign. I like it. So, a peanut. That works for me. So, when we talked about Rose curves yesterday, a sine Rose curve and a cosine Rose curve, what sort of difference did we talk about regarding the location of the petals? And what do you see here? Liam?
The cosine is the 0 to pi line.
Correct. Very good. The cosine petals start on the what is the x-axis, right? And again, it's tied in with the fact that our curve starts at a theta of 0, but with a radius number, versus sine curves start at the pole and then go out into quadrant 1. All good. So that's really it for lemniscates, but Josh asked a good question, kind of piggybacking on our Rose curve exploration that we just went through. Ooh. How would I go about graphing this on a calculator? What would I have to adjust? The square root of that, plus or minus. Kind of the way that you have to kind of beat around the bush to graph a circle on your calculator. You're going to have to beat around the bush to graph this because our calculator only says r equals. We need r squared. So you would have to square root both sides. And type it in 2 separate parts. So the positive square root of 4 sine 2 theta, and also the negative square root of 4 sine 2 theta. And fingers crossed. I will eventually. But I wanted to show that first. So there's our 4 sine 2 theta graph that we just did by hand. Before I do it, let's kind of come up with any hypotheses. What do you think will happen if I add 1? Which means this whole graph is going to shift up 1. So there, I'll just take all my critical points and shift them up 1. I am using a different color, although you can't really maybe see it on the projector. What do we think this would do? Any guesses? Jalen? Perhaps, although I'm a little leery of that because the fact that we only go down by a little bit less almost doesn't matter anymore because we don't use it anyway. Kyle? I think I get why you say taller because the magnitude is bigger. What makes you say wider? Well, this one is shifted over to the right a bit, but this one's actually shifted over to the left. So I think you're on. I definitely think you're onto something. You may be right. I honestly don't know. So we will find out. Goodbye, Mr. Gallagher. So I'm going to insert a +1. I need to keep it under the radical, right? Because if I add a +1, when I square root both sides, it'll be under the radical still. What happened? It might be wider and fatter. But let's, you know what I'm going to do? I'm going to graph both of them on the same axes so it'll be a little more clear. Oops. Don't you hate that when you just hit clear after you type everything in? Negative square root 4 sine 2 theta. Alright, so we already saw the plus 1, and that's still going to be there. When I hit graph, it's going to be graphing kind of the original version, so we'll get a good comparison. Not much. Not as interesting as the rose curve change. And truthfully, I think that the difference didn't matter that much based on kind of, Jalen, what you were saying. The fact that we dipped down not as far as we went up kind of was a void point because we reject that anyway. So it really, truly doesn't make much of a difference at all. The pedal is slightly further out on both sides, and I would say it also is slightly fatter. What if I zoom in? Negative 3 to 3. That's the plus 1 one. Yeah. Kyle, MVP. Well done. That's it. Yay. So those are